Hi, now we will see how concave lenses work. A ray parallel to the principal axis of a concave lens appears to be coming from its focus after refraction through this lens. This focus F of a concave lens is situated on its left side. It is shown by the dotted line. Now the next case, a ray passing through the optical center of a concave lens goes straight after refraction to through this lens. It does not bend at all. Now the third case, a ray passing through the focus of a concave lens becomes parallel to its principal axis after refraction through this lens. The ray enters the concave lens and gets refracted at this point, then becomes parallel to the principal axis. So now we will summarize this. When the incident ray is parallel to the principal axis, refracted ray appears to be coming from its focus. When the incident ray is passing through the optical center, refracted rays go straight, it does not bend. When the incident ray is passing through the focus, after refraction, it becomes parallel to its principal axis. Now we will see the sign convention for concave lenses. Focal length of concave lens is always negative and focal length of convex lens is always positive. Rest of the sign conventions are same that we have seen in the first video. Now we know how concave lenses work. So we can see the formation of image by concave lenses. Now the first case is object at infinity. These two rays are coming from the object kept at infinity. So they are parallel to the principal axis. It appears to be coming from focus F after refraction. So join this by dotted lines and produce it upwards. This is the refracted rays which appears to be coming from focus of the concave lens. This ray passing through the optical center of the lens after refraction goes straight. So when the object is at infinity from a concave lens, the image formed is at focus. It is virtual, erect and highly diminished. Now the second case, object anywhere between optical center O and infinity. This ray is parallel to the principal axis. It appears to be coming from focus after a refraction. So join this by dotted line and produced it forward. This is the refracted ray which appears to be coming from focus of the concave lens. Now this ray is passing through the optical center of the lens. After refraction, it goes straight. The two refracted rays are diverging rays and appear to intersect at A dash on the left side of the lens. When produced backwards, draw A dash B dash perpendicular to the axis. If we see on the right side of a concave lens, we see A dash B dash. So when the object is placed anywhere between the optical center and infinity, the image formed is between the optical center and focus. It is virtual, erect and diminished. Now let's summarize this. When the object is at infinity, image is at focus F. The image is highly diminished, it's virtual and erect. When the object is kept anywhere between optical center O to infinity of a concave lens, image is formed between optical center and focus F. It is diminished, virtual and erect. See this table carefully. You keep object anywhere in front of the lens, in front of a concave lens, the concave lens always form virtual, erect and diminished image. So now we will see how the concave lenses are used. Concave lens is used to diverge incident rays. This helps to create a virtual image on the opposite side of the refracting surface. Therefore, these lenses are used in binoculars, telescopes, cameras, flashlights and eyeglasses. Now we will see the lens formula. 1 upon V minus 1 upon U is equal to 1 upon F. This is a lens formula. Lens formula means it is applicable to both lenses, concave and convex. See the difference. This is a mirror formula. 1 upon V plus 1 upon U is equal to 1 upon F. This is the only difference, sign. Now let's see the magnification. Magnification M for lenses is V upon U, whereas for mirrors it is minus V upon U. So while solving problems you have to apply these sign conventions accordingly. Now we will see the power of a lens. Power of a lens is equal to 1 upon focal length of the lens in meters. That is P is equal to 1 upon F. Convex lens can form virtual images as well as real images. Therefore, magnification produced in a convex lens can be either positive or negative. A concave lens forms only virtual images. So the magnification produced by concave lens is always positive. Concave lenses forms images which are always smaller than the object. So magnification produced by a concave lens is always less than 1. Now we will see more about the power. Power of a lens is inversely proportional to the focal length. A lens of short focal length has more power, whereas a lens of long focal length has less power. Power of a concave lens is negative. Power of convex lens is positive. Convex lens is a converging lens. So converging lens is positive. Concave lens is a diverging lens. Power of diverging lens is negative. With this we have finished all the concave and convex mirrors and lenses. You can go to our previous videos and revise so that the concepts will be clear with you.